Today we are talking about what is called derivatives and data. In the last several years, the AP exam almost every time on one of the 6 free response questions has given a table of data and asked a bunch of questions about it. So Mr. Gilliam and I decided that it would be a good idea to do an entire lesson on problems like this so you know how to tackle them when you see them. Okay? They like just putting data up here because it's not an equation. There's no equation to go with it. So what we're going to do, this is a lot of review, which is a good thing to start off the second semester with, because I know for a fact that you guys have not thought about calculus at all in the last 2 weeks. Am I right?
I thought about that one when you go back to calculus.
Okay. So what we're going to do is we're going to read the question. We're going to work together and answer these questions dealing with this. Then you're going to have about 15 minutes at the end of class to work on this assignment today, and then you're going to have time tomorrow. All right? Here we go. Let's read this scenario that we're talking about here. It says water is flowing into a tank over a 24-hour period. The amount of water W of T in the tank at various times is measured, and the results are given in the table below, where W of T is measured in gallons and T is measured in hours. And they tell you that right on the table. They're real handy as far as that's concerned. There are 150 gallons of water in the tank at time 0. And that's pretty straightforward. Now, usually you think that if you have a big tank and you're filling it with water, you turn the water on. The water's, you would think it'd be flowing at a constant rate. This one's not. The rate at which the water flows changes. Okay? So that's why you just can't figure out straight away what's going on. It's not a linear function. Use the data W of 8. Using appropriate units, explain the meaning of your answer. We are going to focus quite a bit this semester on notation because some of you are very, very lax on how you write stuff down. In college, professors are very write stuff down, so we need to get picky in this class as far as how you note things because they will take points off on the AP test if you don't do it properly. Now this one says find W of 8. This is an Algebra 1 question. Okay? What is W of 8? W of 8 is what? 221. That was hard. That's what you want to find. W of 8 is 221. Now it says using appropriate units, explain what that means. Raise your hand if you can tell me a sentence that tells what this means based on this problem. Okay, Michelle, go.
The water level in gallons after 8 hours is 221.
That sounds great. Okay. The water level after 8 hours is 221 gallons. Did we use the appropriate units? Yes, we did. Is that a good sentence? Yes, it is. Explains exactly what's going on. Okay? Part B. Use the data from the table to find W inverse of 257. W inverse of 257. What is that going to be? 12. Okay. When you write your sentence for this one, because it asks the same question, you have to do it with the numbers in this order. So raise your hand if you think you want to do that one. Somebody different. Somebody different. Can everybody volunteer? Colin, go for it.
When there are 257 gallons in the tank, the water has been running for 12 hours.
Very good. When there are 257 gallons in the tank, the water has been running for 12 hours. Okay? Are we good with that? So those are Algebra 1. We haven't done any calculus yet, have we? Not at all. Okay, but look at letter C. It says use the data from the table to find an approximation for W prime of 15. Why can I only find an approximation? There are 2 reasons. Does anybody know? Why can't I find the exact value?
Because it's not a constant rate.
Because it's not a constant rate. That's a good answer. I want another. There's another reason why. Why can't I find W prime of 15 exactly?
Is it because they gave it to you? They didn't measure it enough.
They didn't measure. There's no 15 up here, is there?
Right.
That's another good reason.
Thank you.
And in order to find a derivative, what do you need to do if you're going to find a derivative exactly? You need an equation, don't you? Think about it. Don't you need an equation? I don't have an equation. I just have data. So it says we need to find an approximation at 15. Does anybody have an idea of how we can do that?
Oh,
Difference quotient was the word that was said. There's another word or another phrase of what
backwards question.
that as well.
Forward.
There's another kind of thing that it's called besides a difference quotient.
Oh, isn't it? Can you do like f of a minus f of b?
Yes. What's that formula called?
Average rate of change.
Average rate of change. So we can use either an average rate of change or a difference quotient, which are actually the same thing with two different names. Okay? Now, so here's where the notation comes in. W prime of 15, it says approximately equal to. So we're going to do squiggly equal signs. Okay? So what numbers should we use to get the best estimate off the table? 12 and 16, exactly. So it's going to be W of 16 minus W of 12 over 16 minus 12 equals. Now we can say equal to because that's what we're turning this into. Does everybody understand how I'm getting all this? 15's in the middle between 12 and 16, so I'm going to use those two. And didn't we find when we did difference quotient that symmetric was the best estimator?
That is correct.
That is correct. So 16 is 294 minus 12 is 257 over 4. Use your calculator. So 37 over 4, 9.25. All right. It says, show the computations that lead to your answer. That's what I did. I showed my work. Then it says, using appropriate units, explain the meaning of this. Well, first of all, I need to label this answer. Does anybody know how to label this answer?
Gallons per hour.
Colin says gallons per hour, and you are right. How did you know that?
Because it's
There's two ways to determine that it's gallons per hour. I want to know which way you did it.
I use my head.
Well, okay, how'd you know it was gallons per hour instead of just like gallons?
Because it's the average rate.
It's a rate, exactly. It's a rate. Now, some of you see, oh, it's a rate, so it's got to be like miles per hour, feet per second, so it's got to be gallons per hour. Okay. Shh. Another way to know that that's the label is as follows, and I need the talking to stop. What kind of values are these top numbers of the fraction? Gallons. What are the bottom numbers? Hours. So it's gallons over hours. Another way to know. Now, writing the sentence for this one is a little bit tricky. The last two periods, what I have done is I have let people volunteer answers, and I've basically given them a number grade as to how close to what it is, how many of the details they've kept into the answer. So I need a sentence explaining how this relates to this.
Wait, which one was it?
How this relates to that. This relates to that.
Isn't it the average rate gallons per hour is 9.25 when
You're not okay. She said the average rate of gallons per hour is 9.25 when the time is 15. That's not bad. I'd give that about a 90. Okay, you got pretty good. But let's put it less in a mathematical sense and more in a water is flowing into the tank kind of a sense. Do you see what I'm saying?
yes.
Take away the phrase average rate of change. Shh. Anybody got an idea of what to say? Justin.
From, what's the hours again?
15.
16 to 12? Oh, okay.
We have to use the 15. We can't use 12 to 16.
Let me try again.
Okay.
I have to think first.
Oh, we have to think first. Sibby, you want to give it a shot?
I have an idea.
Okay, hang on just a minute.
At 15 hours, water is going into the tank at a rate of
95%. Very good.
Wait, what did you say?
She said at 15 hours, water is flowing into the tank at a rate of 9.25 gallons per hour. I would give that a 95%. There's one small detail missing.
It's
Do you want the?
Thank you. It's approximate. It's approximate. Other than that, that was a wonderful sentence. At T equals 15 hours, water is flowing into the tank at a rate of approximately, and I can abbreviate approximately, 9.25 gallons per hour. Very well said. Very well said. At T equals 15 hours, water is flowing into the tank at a rate of approximately 9.25 gallons per hour. Any questions? Okay. Now, I would like you to silently read part D. Read part D. And I would like to see a show of hands of those people who think they could do that by themselves. A couple of you. Only a couple of hands so far. Okay. All right. That's a smaller contingency that I'd hope for. Okay, those of you who say yes, what is the key phrase in this problem that tells you how to do it? Average rate of change. Okay. Of W over the time period from 4 to 20. So, yep, just different numbers. So W of something minus W of something over something minus something. What goes in the first parentheses? 20 minus W of 4 over 20 minus 4. That wasn't very hard, was it? Okay, you finish it up. Okay, because it says to show the computations, you need to go ahead and put in the step here that shows you got to have, it'd be great to have both of these, you've got to have at least one of these two. The first one is really important. But you're basically showing the math. This could theoretically be given to you on a non-calculator part of the exam.
Are you serious? That's a lot of division.
Oh, but the division would be kind of yucky. You're right. They probably wouldn't put that on the no calculator part. You're right. Okay. Have I mentioned in this class how many decimal places you have to go out to at least? 3. The answer is 3. Okay. You must go out at least 3 decimal places if the number goes that far. If the number is a perfect fraction, yes, make it a fraction if you want to. Okay. You can go out 4 or more. This one is exactly 4, so I just left it at 4. But make sure you go out at least 3 or they will not give you full credit. How should this be labeled? Gallons per hour. If you are doing a word problem, just always get in the habit of labeling your answers. It's safer that way. Okay. Now, question E is not that hard. The justification is. It says, for 0 is less than T is less than 24, must there be a time T when the tank contains 265 gallons of water? Is the tank going to definitely hit 265 gallons full at some point?
Yes.
Yes, it's definitely going to. Okay, the question is, why? Why? You can't skip it. Well, that's true. There's a theorem that goes with this.
Intermediate value. It's the value that's in between. There you go.
You're exactly right. It is the intermediate value theorem because 265 is between 150 and 357. That's a great way to remember it. Because intermediate means in the middle, doesn't it? Okay.
Yeah, what was Rawls reading? Remember?
Okay.
Rose is the 0 one.
Rolls is the 0 one where the derivative is 0. It's going to hit the top of the hill. Okay, but in this case, we need to write out what's going on here. We're going to put something to the effect of because IVT, because B/C is an approved abbreviation for the AP test. IVT is an approved abbreviation for the AP test as well. You don't have to write out intermediate value theorem. IVT says, okay, what's the scenario for IVT? Does anybody happen to remember? It has to be between 2 points, but before that, what kind of a function does it have to be?
Continuous.
It has to be continuous. Because couldn't a function rise and then skip and go on and not hit every middle value in the middle? Yeah. But this is continuous, right? Is this thing filling at a continuous?
Yes.
There's not going to skip anything. Okay. So, IVT says since the water is filling continuously, that takes care of the continuous setup. What's the second part? How are we going to put this into words? How do we know that it's going to hit 265?
265 is on the interval of 0 to 370.
Okay.
Or 150 to 150.
Right. And because 265 is between the two, right? And because 265 is between, now, we have to say it this way. Well, where in the world are we getting the 150 and the 357 from?
0.
It's between the W of 0 and the W of 24, because the 0 and the 24 were given in the setup. We have to address that. Okay. So, since it's filling continuously, and since 265 is in between those two, what does IVT say is going to happen? There must be a point how are we going to put this? Where, very good, W of T equals 265. Very well said. This is why we make you learn these theorems, because they'll ask you questions like this on the AP test. They will. You've got to know what the theorems are, the difference between rolls, mean value, intermediate value, extreme value, all these other theorems. Okay? Any questions? Well, now that you've got a model of that, it'd be a little easier to do it if you have another problem that's similar to it. Okay? Now, for F and G, we don't need the data table anymore. F says a model for the amount of water in the tank is given by this function. In other words, somebody took the data, put it in stat plot, and found a curve that fits it the best. This is the curve. Where A of T is measured in gallons and T is measured in hours, find A prime of 15. How do you do that? Plug in 15 to here?
To the derivative.
Oh, to the derivative. Okay. So, A prime of T. Let's take the derivative first. How do you do that? Oh, you slept since then. Okay, is this a chain rule or is this a product rule? Is this inside of that fraction? No, it's not. But it's a constant. It's kind of a, it's a constant product. Let me explain what I'm talking about. Okay. Some of you see the constant sitting there and know what to do. Some of you see product rule. If you see product rule, let's talk about this for a minute. Fraction is 1, parentheses is 2, right? So you would write 1, copy the fraction, D2, take the derivative of the parentheses, right? Plus,
0.
copy this, times the derivative of this, which is what? 0. So you don't even need the 2D1. Does that make sense? So all you're doing is 1, copying the fraction, and then taking the derivative of the parentheses. Like I've told you before, though, whenever you have a fraction in the front, what does it do? It sits there. That's why. You just sit the fraction there and then take the derivative of that. So that's what we're going to do. 1 over 2. Yeah, that's why. Okay, 1 over 225 times. All right, let's get the brains going again. What's the derivative? Tell me. Negative 3t squared plus 60t plus 1800. Yes, your brain still remember calculus. A prime of 15 equals. Now I'm going to use a calculator to do this. So parentheses 1 over 225, negative 3 times 15 squared, plus 60 times 15, plus 1800. Oops, darn it. I've got 180 instead of 1800. 9, exactly. 9. 9 what? Gallons per hour. Why? Because it's a rate of change. It's a derivative. Okay. This is the rate of change at 15 based on the equation. Didn't we find the rate of change at 15 based on the data somewhere?
Yes, we did.
In part C,
And it was
we found it.
9.25
It was
gallons.
close. It was close. Approximately 9.25.
Well done.
Pretty good estimate. Okay? So 9 gallons per hour. Are we good there?
Yes, ma'am.
Any questions on that one? That wasn't too bad. Part G, use the model given in F to find the average rate of change of A period from 4 to 20. Can you do that? Okay. Now, some people would assume average rate of change, oh, that means slope. So when they write this down, instead of putting A of something minus A of something, they put A prime minus A prime. No. Because it says the average rate of change of A, you have to use A. Don't use A prime. This finds A prime for you. It finds the approximate slope, okay? So what goes in the first parentheses? 20. And then here's 4. 20 minus 4 equals. Now remember, we're plugging these into A. I would recommend you take that equation right there, put it into Y equals, and then use the table.
Wait, for what?
Okay, since I have to find the Y value at 20 for this, and the Y value 4 for this, I'm just going to type it into Y equals once. Okay? Let's move it up a little bit more so I have more room here. 1 over 225, parentheses, negative x to the third, plus 30x squared, plus 1800x, plus 33750. Go to the table, go to 20. I don't have to worry about setting a window or anything, I just copy these values down. So 327.78 minus 183.85 over 16 equals 8.99. Now, look at the decimal here. It's 9956. So you can chop it off at the 5 if you want to, or you could round it up. It's up to you. So 8.995. And because it's a rate of change, how should I label it? Gallons per hour again.